If you want to make your applications better and more accurate, you got to be testing hundreds of prompts in the same time period that you were using to test 3. And you got to get your entire team doing that. And if you're not doing that, your system is going to suck and you will not win.
Welcome to episode 30 of Tool Use, the weekly conversation about helpful AI tools that you can use today, brought to you by Enetic. I'm Mike Bird, along with Ty Fierro, and this week we're talking about prompt engineering and structured outputs. We're joined by Viabhav Gupta, the co-creator of BAML. Viabhav, welcome to Tool Use.
Thanks for having me, Mike and Ty. It's always fun to chat with Ty and great to meet you as well today.
It's stoked to have you on. I've known you for a little while, and we always have fun when we hang out. So I'm glad to have you on. I'll ask you the question we start off with everyone is kind of how you got into AI and kind of what made you obsessed with AI to some extent.
So to be completely honest, I was probably one of those non-believers for a long time. I went on to AI from a totally different side. I went in studying at computer vision. And in computer vision, there's two types of people. There's people that say everything should be math, and then there's people that say deep learning all the way. I used to be a math person. So I went in saying deep learning, what is this? This is all garbage, it's not gonna work. And if you go back to 2015 when I was doing that, that was the right answer. Math was way better. Then somehow you get to 2017 and every paper at CVPR suddenly becomes deep learning. And I'm scratching my head being like, what am I doing wrong? So then I said, maybe math isn't the only way. Maybe we can use AI for parts of it. And slowly I've really come to realize that there is beauty in being able to combine models with algorithms to get really good results. And that's really how the most sophisticated systems in the world are built. It doesn't rely on fully AI, it doesn't rely fully on algorithms. Because like AI is this thing that is amazingly, what I would say, it's like beautifully flexible, especially with Gen AI. You can put anything into it and it works. It kind of works. The key part is kinda, but it's horribly inconsistent. And then algorithms, they have this beauty to themselves that it's like they're amazingly consistent, but there's so many scenarios they don't work in. So the trick is, could we combine those two things together and make them work? That's really what got me fascinated into it. And I did this stuff at Microsoft for a while. I did it at Google, working on Face ID and a bunch of AR pipelines. And then eventually went on to join a hedge fund at DE Shaw as well.
Excellent. I wouldn't mind you telling a bit more about BAML. I love the idea of being able to have LLMs as functions and have any model be able to do structured outputs, but I don't want to spoil it too much.
Yeah, I guess you've looked into it, I guess, at that point. But for those of you that haven't heard, BAML is a new programming language that we made. And the first time we say that, people are like, huh, what? Like, why would you do that? We have enough programming languages. But really, for me, it's all about what a language allows you to express. Why did we invent Python when we had C? Because some of us don't want to write memory management and don't want a garbage collector to do the work. Why did we invent JavaScript when we had Python? It's because the web is completely based on very interactive systems where on click, do this. On event, do this. It's a different type of coding paradigm, and it helped to have a language that was cross-compilable across all operating systems and also allowed you to have event-driven actions. No other language had that at that time. Why do we have Tailwind in some sense? Because CSS is horrific, and Tailwind is a lot easier to read. The syntax of Tailwind is better than the syntax of CSS, even though they express the same thing. So when it comes to models, what we thought of is that we probably want us to come up with some way to be able to use models, which again are horribly unreliable, in a way that is universally compatible. And that's where the idea of a programming language came up from. It's that we're entering a new way of writing code where it's not always deterministic. Things will change randomly in a way that we don't control. So we probably need to think about a software differently.
Makes a ton of sense. I'm kind of curious about the most impressive demo I've seen with BAML is like UI streaming. And I think that's just so cool. Yeah. You can see the UI just kind of streaming in there. I'm curious, like, how hard was that specific part to build and what kind of powers that?
So maybe to articulate this, Mike, have you seen this sort of stuff before?
No, love to see more.
Okay. So why don't I just show you a little bit? And I will just screen share my whole screen. So if I leak API keys, please be kind. But let's do something really basic. So I think the number one thing that bemoans most people building AI applications is everything feels like a derivative off of ChatGPT. How are you not a ChatGPT clone? So I'll do something really simple, which is a recipe generator. This is powered by OpenAI, but I don't think it feels like it is. What are y'all's first impressions when you see this on the screen, where it's kind of like dynamically loading in content for me?
I know how hard this is to do, to try to do this manually with the OpenAI SDK. So it's like why
Exactly.
I'm so fascinated with this idea of like generative UI, and this is such a great primitive for it.
Yeah, and I love the consistency. Like it's giving you exactly what you want in the place you want it.
Yeah, so the way I've always looked at this concept is that there's two parts to this that we have to do. One is we have to build the UI. That just takes time. If you're going to build a UI, we all know how to build UIs. Like this is just a React component. And what's cool is I can even play around with it while it's loading. You could ask any freshman in college and they can build this UI with like some state built in based on if it's loading or not. All they need is a consistent schema to come back to you. And then this part becomes really easy. So the hardest part here is actually not about building the UI part. It's really about defining the state model in a way that makes sense. That's what BAML makes really easy. Over here, you just define your state model as this thing that tells you the topic, the number of servings, ingredients, and just goes through and just pulls out a data model that is going to be exactly that every single time. And then you just render it. That part is like the easiest thing. The hardest part is really coming down here and like defining what the state model is and somehow getting a model to produce that reliably. You can do this in a few other scenarios like resume parsers. If you want to go ahead and build like a resume parser, it's really easy to build something that just streams that markdown. What ends up being quite challenging is building something like this, where, again, this looks impressive, but it's just a React component on a data model, and I'm just rendering this data model for you. That's all I'm doing. All BAML is doing is just somehow getting that data model out from the model without you doing any work. I was gonna say, if you take it to like the nth degree, it gets a little wild because, and this is live, so we'll see if this works. But like you can take like this visa form from Cambodia and do the same thing, where this time I'll have the model even define the schema for me at runtime. So it's actually defining the schema right here. And then once the schema is executed, it's actually gonna run that schema. And now you get this data out. And what's interesting is, check this out, first trip to Cambodia becomes true from check marks. And true is a heck of a lot more useful than a check mark, where OCR could never capture something like this. But the trick really is that everything in here is a data model. So if we find the thing that is first trip to Cambodia somewhere in here, this is just a Boolean type. So the model knows that we have to extract this out as a Boolean.
Wow, so it's just dynamically generating BAML code itself and then extracting that out to structured out. That's crazy.
Exactly. So like, why does BAML come into the picture? It's because this code, the analogy that I always use is, again, like Tailwind or React. They're all doing the same thing that we could have done before. We always could write HTML, we could always write JavaScript, and we could always write CSS. But somehow there's some magic that happens when you write it in React or Tailwind syntax that didn't allow you to build something without that. The same thing is true here. We basically express the syntax in a way that's a little bit more expressive to the model, and we're able to write new algorithms on top of that, so that when the model outputs something, we can kind of guarantee that this part of the data model will be exactly this shape, no matter what. And that's what allows me to very confidently run this demo and actually show you this. And I can do it with like a real-time image if I have one. I have like this coffee blend. Let's see what it does. Or a tea packet, I guess, is what it actually is. And you're going to see right there. It just worked.
Very cool.
Right?
We love a live demo.
The thing is, like, models, in my opinion, are really, really powerful. People are just really have a hard time adding the reliability layer. And like, imagine if you built a website and we didn't have React to do component re-rendering, didn't have TypeScript to check all your errors. Your website would be broken all the time. That's really the layer that BAML adds on.
So a lot of the people that have been watching this have played around with structured output. They might have a little demo hacked together. What would you say the difference is between implementing BAML in a project versus just relying on OpenAI structured output?
Yeah, that's probably a great question. One, do you want to rely on just OpenAI? That's the first question to ask. Probably not. And that's where BAML really helps. We support structured output on every model, even if the model doesn't support it. And 2 is just more of a philosophical question. Structured output from OpenAI relies on JSON. Do we really believe JSON is the best serialization format for models to answer questions with? And that is really the crux of the problem. I think I haven't run like a proper experimentation suite on this, but I know a lot of people have, where they said that migrating from non-structured output to structured output reduced their quality. And have you guys seen that? Is that something that you experienced, or have you found like mostly it's been good?
I have seen on Twitter where it degrades quality. I love structured output, so I hate to hear that, but I do I do love structured
Yeah,
outputs.
we all love structure because that's how you build these components and everything. But there's a couple of things that become really impossible when you rely on JSON. And I think it's hard to describe because it's like trying to describe Tailwind without seeing Tailwind. So like maybe I'll try and show you a couple examples, and not really in BAML, just like conceptually. That'll give you a better idea of like the theory behind why that's the case. So if I go back and I talk about like structured outputs, and let's say I want to ask a model to spit out JSON, and let's say the model is going to output a name like this. This is pretty good. The model can probably do this very reliably. But do you see a mistake here? This comma is extra. This will fail my JSON parser. So I better hope I got this right. Now let's say I ask the model to make a story for me. Now all of a sudden it gets a little bit trickier. Watch this. He said, I'm going to build a startup. If I don't get these quotation marks right, it's going to mess up. Wouldn't it be so much easier if the model could just output this and didn't have to think about it? Or perhaps even this and didn't have to think about it? Where you can remove the quotation marks and all the escape characters. The only reason we use escape characters like the quotation marks and backslashes is because of JSON parsing. What if we could just do this, where we took out all the quotation marks that weren't relevant except for the actual content, and somehow it still worked? Similarly, if you're outputting code, dumping code in JSON is really hard. Like this is what your code has to look like. I should turn off autocomplete on cursor because it is not good. And you can see here where just the number of escape characters I have to write this simple line, which is just adding 2 numbers, it makes it very hard for me to actually read this code. And probably if I had to, as a human, write a more complex piece of code, I wouldn't be able to. On the other hand, it again goes back to flexibility of what the model is allowed to do. But I'll show you like this one sample code of what happens. So I have a function. This function is going to take in a request by a user, in this case, implement a binary search tree in Python, and it's like a pretty complex concept. And I want it to spit out the code to me. Watch things that the model is now able to do. The model can do reasoning and chain of thought as it's answering. And when it dumps out the answer, it actually dumps it out as a markdown snippet that looks almost like JSON. But it's not perfectly JSON. But hopefully you can get an intuition as to why not requiring escape characters here, like backslash new lines or quotation marks, lets the model produce better code. And why chain of thought before answering lets the model produce better code. But if we look at the right side, we see that the only data we got was the actual code, in the code snippet, and we didn't have to do any parsing or anything with it. That's kind of what BAML does for you. It's basically a new serialization technique to use a model and get the behavior of tool calling and function calling without having to train a model to do function calling and tool calling explicitly on JSON.
Wow. I remember a couple months ago when OpenAI came out with their structured outputs, they're like 100% reliable structured outputs, whatever. I saw you at AI Tinkerers, and I was like, oh man, I saw the OpenAI drop this thing. You're like, bro, we still outperform them across a bunch of benchmarks. So that was really impressive.
Well, yeah, because OpenAI, what they did is they didn't get 100% reliability. They said it was 100%, but what they really said is we have 100% parsability. 100% of the time, you'll be able to parse the data you want. And they still don't do 100%, so like there's that too. But like 100% of the time, you can parse the data you want. But that doesn't mean you get the answer you want. Take a scenario where you built a system that uploads receipts and you use structured outputs. And then imagine your user is a pain in the ass and uploads a resume. There's no receipt that makes sense for that data model at all. You just can't do it. There's nothing that would make sense to go do. you can use BAML and not have to worry about that. You get the right behavior, which is we raise an exception in that scenario, because there's no way to contort the data model the model spits out into a receipt because it's a resume. And that concept is something you can't fix at the model layer, because the model is doing its best job of outputting the best tokens. Really, the models are amazing at that. Unstructured output says, hey model, stop. I know better than you. Only output these tokens that I allow you to output. But that's what we used to do in computer vision a few years ago when we didn't trust the models. We'd say, hey model, I won't let you do everything. Let me clean up the image first, and then I'll let you do your post-processing. And that was just wrong. It turned out the idea was let the model do what it does best. And that's what we say here too. Let the model do what it does best. And then see if there's algorithms you can apply later on that do error correction techniques on what you know.
One common thing we hear from all the guests on tool use is that it's too hard to stay on top of AI news. There's just too much happening to stay abreast of everything.
So we built Enetic Daily Intelligence, a daily newsletter that helps you stay on top of AI news that's personalized to you and your interests.
So head on over to enetic.co to sign up for the waitlist today. Thank you. I love the idea of being able to get more reliable output and, like you said, allow the LM to do what's best. If I want to put this in a project, am I rewriting the whole thing in BAML?
No, don't do that. Please don't do that. I tell everyone this. People are like, oh my God, this is cool. I'm going to go. I have met so many people like, I have like 100 prompts. Let me go rewrite it all in BAML. I'm like, please don't waste your time doing that. The thing is, like, systems that we're building now are all about probabilistic distribution. So find the parts of your system that matter the most. Swap that one over. Why waste your time doing everything? Just do one at a time. You have a new part of your pipeline you're writing and you want to be able to use DeepSeek on it, write that in BAML. But don't change your old code. Like you will have more AI application code next year than you have this year. So just roll forward. It's compatible with almost every system. I think when we started our journey, this was actually the first question we asked ourselves. I mean, one, like how dumb are we to make a programming language? Pretty dumb. But two, there's this really serious tax that someone has to be willing to sign up to use a language, because it's like it's almost as critical as like, oh, am I going to build my app in like Angular or React? It's a decision you make, and it's hard to go back. And one of the things that we explicitly didn't want to make possible is making it easy to go back and forth between the systems to support whatever you want. So like one of the design decisions we made is you don't have to write your whole app in BAML. In fact, the other design decision we made is we want BAML to be compatible with everything. So like whether you're writing TypeScript, Go, Rust, Ruby, Java, PHP, I don't care. You can just use the same exact BAML core in all the same languages. Because like when I saw LangChain, like, I don't know what y'all's experience was with LangChain, but like they came out with a Python version. And I was like, okay, fine. I guess some people think it's useful to have a wrapper around calling an API, which it is. Abstractions are nice. But then you get into this world where like their Python code and their TypeScript code are totally different. And they have totally different bugs in both of those systems. And there's no way to use either of them. You have the same problem with Instructor and most frameworks, because most people write the frameworks in the language that they know best. And then they try and adapt it to everything else.
Yeah, I've had some problems with Instructor and also LangChain specifically. I've avoided LangChain like the plague. I've tried Instructor and it's all right. I'm kind of curious what your I know BAML is all written in Rust, and I'm curious what your decision was for Rust and why you chose Rust as like the primary language to build this.
Yeah, Rust was a hard sell because I actually didn't know Rust when we started this company.
Wow.
I spent 10 years building C++ systems. So like I optimized a ton of computer vision algorithms, made some things like 1,000 times faster, made some things 100 times faster, all writing in core assembly for a while. And that's what I did for a career. And at some point when we were starting this idea, we said, let's make a programming language. And we had a couple choices. One was write in TypeScript or Python. But philosophically, that was wrong. Like I can't write a compiler that takes 200 milliseconds to boot up, right? Like no one has been happy with the TS build times. No one's happy with how long Next.js takes to build. What I love is when I type things and they show up. To do that, you got to be fast. So speed was constraint number one. So that ruled out most languages. That means now we have C++, And that was really the only language. So the first version of BAML was written in C++. And then we realized we're going to have to build a team. And no freaking ways are we going to build a team that all writes C++. So we said, okay, it's not C++ because my co-founder vetoed it. It's not Python and TypeScript because I vetoed it. So we compromised on Rust, which neither of us knew. But it turned out to be coincidentally quite a good thing because Rust is a language that prioritizes testing. Tests are beautiful in Rust, and that's something we were inspired by in BAML, actually. We made test a first-class primitive of the syntax. You don't have to install a package manager. You don't have to install anything. You don't need separate files to write tests in. You just write tests, and you can write them anywhere. That means your code is more often tested. It's easier to debug issues, and your code stays battle tested for a longer time. But then the real reason was that we want to support every programming language. So what we do is our whole engine is completely Rust, and then we have a binding that is very thin that we build up for every single language. So we ship a binary in Python, we ship a binary in Node, we ship a binary in like Ruby and a bunch of others. But that layer is very thin and allows us to maintain our execution speed without taking on a huge tax to support any language.
What type of interaction do you get with the users of BAML? Do you get feedback from them in regards to like the how well it is?
The beginning was rough. The beginning was rough. It was really rough, in fact. Imagine using a new language. It doesn't have a syntax highlighter. Its compiler breaks all the time. It's a rough world, but we were fortunate that we had a couple people that had opted in to this misery and joined us in that, and they helped us out in the first 8 or 9 months quite a lot. We had like less than like 20 users for the first 8 or 9 months. Since then, we have a very active Discord community of like 800 plus folks. We've grown like our user base, a couple hundred teams that have all went to production, which I think is the best part of what I'm really excited about BAML. Everyone that tries it for the first time is like, holy cow, I can go to production now. Because it just works, and they're surprised by why it works. But I think that's the beauty of a compiler. You don't think about why Python works or why React works, it just does. So we get a lot of feedback. We're starting to get ideas from the community too about new syntax to add in. So that's been fun, and then it's all open source, so we get some contribution as well.
Kind of a related question to this is, what in your definition, like what does a great developer experience look like? Like what constitutes a great developer experience
when
for
I don't
something
have to
like
ask
this?
questions. Like, I think I've been coding for a bit now, and like sometimes I look at code and I'm like, damn, that's sick. But you just get this thing where you're like, damn, nod to that developer. They did a great thing. And I think one of those is like when I experienced that for the first time was when I experienced how easy TypeScript was for autocomplete. I was like, damn, that's nice. I was a vehement non-believer of React. I was so non-believer of React for a long time that I actually made my own version of React. That I just had everything in it. I had like page routing, it had like component re-rendering, a whole bunch of weird things, state management, a whole bunch of things that I built. I did not have component render, but I did have state management and a whole bunch of other things. And now I don't know why I did that, because when I used React, I'm like, they did some things some things were wrong, and they're fixing that with a new version of React. React 19 is the first step in the right direction because they're actually building it as a proper compiler. But some things were really well done. When I used Tailwind, I again hated it in the beginning, but it took maybe half a day to learn. Like an hour or two, and then I was just like, autocomplete just works. And for us, that's what we prioritize in BAML as well. When people start writing BAML, that's why we have like what we think is the most important part of writing BAML, which is like when you write prompts in BAML, everything is written like code. A function has parameters, it has a data type, you write what model you want to use, you can use any model you want. And any provider you want, and you write your prompt. But I think the best part is you can actually see your prompt in real time. You change your prompt, and this thing changes right here. So if you change something, you change your data model, you change like name over here is right now first last. I'll change name to just be a string. My prompt changes to reflect that without me having to think about it. So I'm writing in code while I'm getting LLM stuff. It feels much more structured, but then eventually you can just run your test. So you can see what the model did versus what BAML did for you, and it becomes very easy to rationalize around it. And you're like, oh, I wrote a unit test. Why? Because this failed, because name is no longer first last. and that doesn't pass, so like we can say name, Viabhav Gupta, and boom. And if I rerun this, it should in theory pass. But this iteration loop of being able to edit prompts in real time and be able to just run them without writing a whole testing framework or having to switch to like a website that I have to log into is one element of the developer flow that I was very fortunate to have a co-founder that was able to like think of things like this.
Making a VS Code extension was really smart too, because that's right there where the users are, right there where people are developing, and then they can see it all happening in real time, especially for something that's kind of, I guess, confusing to the first glance of this new programming language. But if you can see it right there working in the terminal or in your editor, that's really clever.
Well, it's not even about like a new programming language. I think actually it's like a new paradigm we're trying to enter. So like take the best designers you know. What do you think makes them amazing? What's your intuition? I'm not a designer, by the way. I'm a horrible designer. But what do you think makes them interesting?
Off the top, I'd say taste. I mean, just in one word, just having taste is, I think,
it's
more important
taste,
than anything.
right? And I don't even know how do you think they got that taste? I don't know. It's like, my intuition is that they've iterated on thousands of design over their life, and now they have taste. That's it. And I think models are really similar too. I think the way you get taste is by running things thousands of times. But if it takes you 4 minutes to run something because you have to set up your PyTest and plug in the right things to like configure the model in the right way to go call it, that means in 20 minutes, you're only going to be able to test 5 things. If all you have to do is hit play every single time you change something, you're trying like 200 things in 20 minutes. You just get taste faster and better.
How does BAML, is there a prescribed way of doing evals, or how do you approach evals if you were to implement this?
I think everyone that is trying to build evals is doing it wrong. Here's why. There's a reason we don't write unit tests for our front end code. It slows you down. It does not speed you up. You don't want a unit test front end code. You just want to look at it and see if it looks right. Because most people are getting into AI for the first time and they don't really have like comparative systems to go build, I think more people should just be running the code and seeing what the results are. That's what I think the first step to evals are. That's level 1. And that level is a pretty thick level, so you should stay there for a long time. Because there's nothing better than just seeing the results and like building your own mental model for like, oh, that's good, that's bad, that's good, that's bad. Here's, this field is bad, this field is good. And then after you get past that point, then you get to this next level of, okay, I have a pretty good sense of what taste for this problem and what it's like tweet sentiment analysis or like extracting data from visas like we were talking about earlier. Then you start saying like, okay, what do I do now? Now you're like, I don't want to have to build taste every single time for this problem set. I have a pretty good example test. Then you write asserts. A lot of people use LM evals. Please don't do that. You have a data model. Just eval the data model in a way that, like in my resume case, I know the name should be Viabhav Gupta. I don't need to ask an LM, is this correct? That's really the answer, in my opinion. Like write asserts on data models, not and then every now and then you vibe code and you write a little LM testing. You know, there's nothing wrong with that. But you don't want that to be 90% of your evals.
So take this kind of a little bit of a different direction. I know you did a workshop a while back on prompting, and I'm kind of curious for our listeners, kind of your top tips, your do's and don'ts of proper prompt engineering for,
oh, yeah.
For
I'll tell you
things.
the top 3 mistakes I see people make in their prompts. 1, they make the mistake of, of doing things like, I'll tip you $5 and believing that actually helps the model. Like, no, it doesn't. Like, there's like infinitely better things that you can do to make the model better. And like, that is the worst strategy of them all. 2, people don't read their prompts. I've met so many people that have just not read their prompts, and prompts just have contradictions in them all over the place. And there's a reasons why they can't read the prompt. Number 1 is like they're using like 7 different frameworks to assemble their prompt together, and they have no idea what actually goes into the model. Like that's one of the reasons we really like BAML is that Playground is like a live preview of your prompt. It doesn't force you to read it, but it makes it so reading isn't hard. Read your actual prompt. Like read, we're all familiar with RTFM, like read F manual, right? There's a reason that exists because it's such a good thing to do. And the model can't do something if your prompt tells it to do two other different things and that disagree with each other. It will be wrong. And lastly, the mistake that I see people making is that they write really, really long prompts. I think somehow there's this misconception that more words is better for the model. This is probably in line with like AI generated prompts as well. There are more words for the model. But imagine I was on here saying like and every 30 seconds. This would freaking suck. I'm hoping, your editing team will take out all the likes and ums I did say, except those two. But other than that, it just wouldn't be fun. So when you add words that don't add value, the model has to do extra thinking to remove all of that stuff out of your context. That's hard, right? That's not a thing that you're adding complexity, not adding value. That's not to say longer prompts are necessarily worse. You just want longer prompts where every word you add adds value. If your word is no longer adding value, take it out. Those would be the top three things I would say. And then the last thing you can do is just like use BAML. Your prompts will just get better.
How do you feel about people adding XML tags into it?
Again, it depends on your data. Are you adding XML tags around HTML? Don't do that. That's dumb. Because that's the wrong delimiter for HTML. Right? Are you adding XML tags on other things with a bunch of nested XML tags? Don't do that. That's dumb. Pick the right UX is what I would call it, or I guess MX, model experience, for the prompt based on your data. It's very data specific.
Interesting. Okay. I'm also curious, what kind of taking this another different direction. You're a founder. Going through YC. If you've had some success with BAML, what advice would you give to new builders in the space around entrepreneurship and around building AI products in this day and age?
Well, I wouldn't say success with BAML. I would say we're successfully not dying. We seem to have some people that truly love using BAML. But I think the advice that I would give is, one, please find a co-founder. It's just so much harder without one. Two, quit your job and go do it for real, or don't. That's really a big one. I was struggled with that for a long time. And then three is probably don't be a founder, is what I would say. Being a founder, you folks probably know, this is in my eyes, you make less money, you have less influence, you have less impact, you have less time, you're just doing everything worse, and there's no real upside at all. Yes, in theory, you can make billions of dollars and be Elon Musk or Bezos or whatever, but no one really, that's not the thing that drives us day to day, even if that ends up being an outcome. And to get to the point where that possibly even happens, you go through so much that is just worse than every other outcome in life. You could just work a job, have way more time, have way more money, and be some VP at Google or something. You'll just have a better life. And the journey to get there will also be better and easier. So I don't think most people should be founders. And if hearing this, you're no, I still want to be a founder, then you should be a founder. Because the only reason to be a founder is because you want to. Because every other reason is not a real reason. It's just there's no good reason. It is worse on every aspect of life to be a founder. But it is better in this one aspect, that is you're a founder.
That really helps you be mission driven. What are you hoping for with BAML? Just mass adoption, or trying to change the way people think about prompting? What's the end goal?
I don't know. I've always really enjoyed software. I love software. Software is like a form of art to me. Some people draw, some people paint. I code. I think as a programmer, we've always imagined what certain pieces of software look like. Some people are like, oh, I want to build an app that's going to inspire people. I truly just love code, and it's going to be amazing for me personally if it feels like other developers love code that we built that helps them write more code. So that's really a big part of it. And if we can help shape a new paradigm in some way or some form, that's just cool. It's just cool to be a part of that journey. I've met one of the co-founders of TypeScript, and it's just cool to see people like that have achieved, in some ways, a paradigm shift in people's mind of code. And since that is a medium of art that I love the most, it would be amazing for me personally to go do that. And then really a big part of it's building a really fun team and culture that we have here. My first team that I worked at Microsoft was the HoloLens team. And it was such a fun team. I remember I was by far the dumbest person on the team. Everyone else was like PhD of some kind, doing computer vision for years. I had no vision background. I came straight from undergrad. I don't know why I belonged there, but they really answered all my questions. They really helped me learn a lot. I remember not just working really hard, but also like going out to bar crawls with them and just having a fun time as a team. And I'm friends with many of them 10 years later. I hope we can do the same thing at Boundary.
One last question for me is, what are you most excited for over the next year for model releases or kind of just new technology in the AI space? Is there anything you're looking forward to or
I
excited
think
about?
this year is going to be the year where a lot more people start to uncover the real ways to attach outcomes to models. It's not really about model releases to me, because if you ask me, I think GPT 3.5 was already enough to solve over $1 trillion of problems. I think people just have to use it well. I mean, technically you could make Roller Coaster Tycoon in 1990s. It was a pretty good game. You just had to use the computer better than most people could. And now we get Slack with 70 gigs of RAM. So pretty good, right? Almost the same thing, but it's different. It gives you different benefits. And like we can all wait for GPT 26, and maybe that'll solve the problem. But like, I think we're already in the era today where a model can solve almost every problem that a business, I won't say that a business has, because there's a lot of people problems with businesses, but like a lot of like data problems can be solved with today's models. And I think this year will be the year when, for the first time, a large group of people will be able to like understand that relationship. And hopefully, I don't know if it'll happen this year. I'm not that optimistic, but I think that by next year we'll have real systems deployed in place. So I'm hoping for like seeing more content online about like people discovering ways that they saw a model be useful.
Absolutely. Last question for me. What AI tools do you use in your workflow, in personal life?
That's a good one.
What's your favorite model? All that fun stuff.
Yes. What's my favorite model? I actually rotate between all of them for a couple of reasons. And my pattern is whenever I have a question, I literally just ask O3 Mini, Sonnet, and Gemini Flash 2, I think. I just plug it into there and see which one responds first, because I care more about the speed, because most of them are pretty good. In terms of coding, I've tried Cursor and Windsurf. They're both very helpful compared to VS Code, but probably the tool that I use the most is Copilot, to be completely honest. Copilot is amazing. It's just like faster tab for me. And Cursor tab is just not good enough for our code base, because I don't think these models understand Rust very well. I don't know how you guys feel about model-generated code, but I've used vSphere, I've used all these other tools. And they're amazing for prototypes, but I've never seen any of them architect good code. And because we built a compiler, we don't really have room to write bad code. Yeah. It mostly has to be designed from the very beginning. And there's not a lot of sample code out on the internet of how to build compilers. It's probably the minority of all the code that exists. So it's hard to like rely on the model a lot for those systems. But autocomplete with tab, that's great with Copilot.
Great. Well, it's been super good having you on, and super fascinating. I'm going to go do some digging into BAML. You've really, that generation of the BAML script kind of blew my mind, where it was generated the BAML code right there, and then just
we have
ran
an
it
example
right
on
there.
our examples repo that does that. We should probably put it on our website, because it's just like, it's surprising how good the models are when you give it really good data models.
Nice. Before we let you go, anything you want to plug to the audience?
Go play with models. Go iterate more. Like whatever tool it is, whether it's BAML or something else, it doesn't really matter. If you want to make your applications better and more accurate, you got to increase your iteration loop. You got to be testing hundreds of prompts in the same time period that you were using to test 3. And you got to get your entire team doing that. And if you're not doing that, your system is going to suck and you will not win.
Wow, strong advice. Yeah, that's a great closing spot right there. Well, thank you so much, Viabhav. Really appreciate you coming on, and maybe we get you on in the future.
Thanks for having me. This was really fun.
Absolutely. Have a good one.
See ya.